Hello everyone, today we will model a case with porous media. The simulation today involves a pipe with a 90-degree bend with a diffuser and settling chamber with an installed mesh and perforated plate. Let's start with geometry and change the units to millimeters. Next, create the points showcased in the table on screen. You'll then want to press the Fit All button on the right side of the screen to more easily create further geometry. So you can see here, based on the following points, we will create a circle for the inlet pipe, cone for the diffuser, and the cylinder for the settling chamber. First, start with the circle tool by clicking the middle and radius points on the left to create a circle. Next, we'll create a line for the circle to pull to by pressing the line tool and doing a horizontal and vertical line as shown on screen. Now, we'll need an arc, which we create using the arc tool and pressing the middle point and two radius points as shown on screen. With the lines and circles set up, we can use the Create Surface tool to make the circle into a surface. Now we can use the pull operation to pull the circular surface along the line 3 times for a finished duct pipe. The yellow line that appears is the direction that the pull will be happening. Let's move on to the diffuser, where we use the cone geometry and select the bottom center point and the outer point, and then do the same for the top 2 points, resulting in a cone. The last volume we have to create is a cylinder, which we will simply generate using the cylinder tool and middle point of the diffuser, the radius point, and the top to indicate the length. This cylinder will represent the settling chamber. Now we need to combine all 4 using the Boolean adding operation. Select them one by one, and they will become one volume after all additions are complete. Now for the porous jump, we need to create a surface inside the settling chamber. So create the points showcased in the table on screen. Now we can create a circle using the newly made points and also use the surface creation tool to create a circle surface. Now with the geometry completed, we can begin with naming. The entrance of the pipe will be called inlet, the end of the settling chamber will be called the outlet, and to do the final naming, we hide the body, access the inner circle surface, and call it pour jump, and the remaining geometry will be walls by default. For the porous domain, we won't need to set it in geometry as we will do so in the mesh, which we can now advance to. In the Mesh tab, we can use the default cell size and select the surface refinement zone as surface with default settings, with the exception of specifying the type as porous. We can now select the name to be pour jump and press preview to make sure the correct surface is being selected. After confirming, press add and apply and close. For the next step, we will select the volume refinement instead and specify the type as porous and set the XY coordinates for the start and end of the refinement as shown in the table on the screen, and local cell size can be left as default. Now we can see here after previewing that the volume inside this red box will be patched as a porous structure downstream from the mesh. After confirming our selection, press add, apply and close, and generate mesh. After the generated mesh is done, we can do an X direction section to make sure the cells for the mesh look appropriate, which they do, allowing us to move on to the setup tab. In the setup page, change the model to k-epsilon, and for the domain, we see the porous option, which we will open the dialog box for and change the length to 0.05 and x of 100, y of 5, and z of 100. Now we can do the inlet, where we will set the x velocity to 5 meters per second and change the length scale to 0.1. For the outlet, we will leave everything as default and apply it and do the same for the wall. Lastly, for the interface, set the geometry name to pour jump, the type to porous, and the loss coefficient to 3. With everything set, we can move on to the solution tab. In the solution tab, we will set a monitoring point at 0.3 for x, 0.6 for y, and 0 for z, and set select velocity as our variable. Now we can press run. Once the simulation is done, we can move on to the results tab. In the results tab, create a plane in the default location and select velocity as its variable. As you can see here, there is a drop due to porous structures. There's a drop in velocity, and it doesn't extend to the outlet. Let's create the second contour and let's see the pressure field here. We will hide the previous one, and you can see the pressure field is uniform downstream of the mesh and perforated plate. Thank you for watching and happy simulating.